Okay, welcome to 4.3 Triangle Congruence by angle, side, angle, and angle, angle, side theorems. We're going to learn two more theorems today to go with the two theorems we learned in the previous section. Our objective today is to learn to utilize those two theorems to prove that angles are congruent. The SOL hasn't changed from 4.2, so I won't belabor that at all, and we'll press right in. If you recall from 4.2, we learned the side-side-side postulate, and what the side-side-side postulate told us in short was that if all three sides, if the corresponding sides, three sides of a triangle are congruent, then the triangles are congruent. Okay, and you can see the picture there. And then the side-angle-side postulate told us that if we had two congruent sides and the included angle is congruent, then we again can show that those two triangles are congruent. Alright, what we're going to do today then is take a look at two more combinations that allow us to tell whether or not angles are congruent. Alright, let's take a look at the first combination here. What you can see here is I have two sets of congruent lines and two sets of congruent angles. So let's go ahead and build ourselves a couple of triangles. So I can take this one, and I'll take one of these over here. I'll stick this on the end, so I've got an angle on the end of it. And I'll take this one and put it on the other end right here. And it looks like with an angle and two sides, I kind of built myself a triangle. I'll take this other one right here. I'm going to do the same thing. I'm going to build another triangle here. And voila, I have two triangles. Okay, what we can clearly see here is I can then overlay those two, and look. No surprise there, I've got two congruent angles. So what does that tell me? Well, it tells me if I've got a side with two adjacent angles here, or if you prefer, two angles with the included side all congruent, then I have two congruent triangles. So if two angles in the included side of one triangle are congruent to two angles in the included side of another triangle, then the two triangles are congruent. Okay? Kind of pretty much running along the same things we did with the last two postulates there. Okay, you can stop the video and write this down. Okay, I'll assume you finished writing it, so let's go on to the next slide. Okay, let's take a look at this this figure right here and kind of use our newfound knowledge. And what we learned with our newfound knowledge was that if I have two angles with an included side, I can show that the two triangles are congruent. Well, what have I got here? Well, it looks like I've got a congruent side, and I've been given a congruent angle. And that angle is a right angle. I've got this right angle right here, and this right angle here. And those are congruent, and these two sides are congruent. Okay? But I need another angle to use what it is. Well, as luck would have it, I can use the vertical angle theorem to show that these two angles right here in the middle are in fact congruent as well. And what have I got here? Well, now I've got two angles with an included side in between them, and I can show, therefore, that these two triangles are in fact congruent. Cool? Alright, let's change things up just a bit. What if I told you that line segment DS was congruent with line segment WO? Those were on the outside there. And of course, angles S and O are congruent as well, these two right here, because they're both right angles. Can I prove that these two triangles are congruent? What have I got here? Well, I've got two congruent sides. I'm sorry, I've got one congruent side and a congruent angle. Okay, can I show it? Well, I go back to that vertical angle. I've got those vertical angles there, so I've got that as well. Okay, so what I've got here now is I've got a side and two angles, but the side's not in between the two angles. Alright, can I somehow prove that these two triangles are congruent? Okay, again, stop the video, see if you can figure out how to prove these two are congruent. They are, in fact. You just need to show me how to do it. So stop the video now. Alright, let's take a look at this then. Okay, so what have I got here? Well, I've got my two right angles there, so those are congruent. I'm given my two outer sides there. Those are congruent as well. And I've got my angle DHS and my angle WHO, the two vertical angles, and I know they're congruent. So that's what I know so far. Okay? What else do I need to know to make these congruent? Well, I can't use any of my tools right now because it doesn't match any of them right now. I've got a side and two angles, but the side's not in between them. So I need some more. Okay, well, here's what I can do. Okay, if you broke the code here, you notice that two of the angles in each of the triangles are congruent. So if you reach way back to that two angles theorem, what did it tell us? If two angles in a triangle are congruent, then the third angles must be congruent as well. So I therefore know that angle D is congruent to angle W over here. Voila. All right. So now what can I do? Well, if I look at this now, I've got my angle S and my angle O, but now I've got angle D, and I've got the included side here. Angle W and the included side. So, what theorem can I use to prove this one? Well, I've got the angle side angle theorem. Okay, I'm now set up to do that. And let's just go through and prove it real quick, and I'll do it in small writing here. I've got a whole lot of room to write here, but we'll go ahead and do it here, and I'll do it in column format for you. So we're going to start out with knowing that ds is congruent to WO, okay, and that's given. I also know that angle WOH is congruent to angle DSH. Those are my two right angles. That's also given. Okay, and what else was I given? Oh, and then I figured out that angle DHS is congruent to angle WHO. Why do I know that? Because the vertical angles theorem. Okay, now that I know that, given those two, I now know that angle, let's see, SDH is congruent to angle OWH. How do I know that? By the two angles theorem. You guys almost forgot that theorem, didn't you? Well, there it is. It's back. Okay, and now I can now prove that triangle DHS is congruent to triangle WHO. Why? Because I can use the angle side angle theorem. All right, pretty cool. But wait! What have we done here? Go ahead and pause the video if you want to write this down, because I'm going to erase it here in a moment. Actually, I don't need to erase that. I can just erase what's up here. All right. Let's take a look at what we started at with this theorem here. Okay? I started knowing that two angles were congruent and a non-included side was congruent. And from that information, I was able to prove that the two triangles are congruent. So what does that tell me? I've got a new theorem coming. All right, here it is. The new theorem, the angle side theorem. Yes, if I have two angles and a non-included side that are congruent to the two angles and corresponding non-included side of the second triangle, then the two triangles are congruent. Okay, so another one, angle side. You guys just proved it. Okay, pat yourself on the back. You proved it, so you know it must be true. All right, you can go ahead and pause the video again if you want to write this down. Otherwise, I'm going to press on. All right, and here we are at the summary for 3.2 and 3.3. What have we learned? We've learned that there's 4 possible combinations here of proving that triangles are congruent, finding just 3 components. Okay? We've got the side theorem, which told me if all 3 sides are congruent to their corresponding parts, or the angle side, which told me that if I have 2 sides congruent with the included angle, that the two triangles are congruent. I have the side angle, which I just proved, which said I have a non-included side plus 2 angles. And finally, I have the angle side theorem, which told me... Okay, I said those wrong. I said side angle, angle, and then finally angle, side. All right. So those are the 4 things you've got in your toolbox now, along with those 2 angles theorem, to prove that triangles are congruent. Now here's two combinations that don't work. Okay, I kind of lied to you in 4.2. I told you there's only one. There's really two combinations that don't prove that triangles are congruent. The first one I told you last time was the angle, angle, angle. And this time the other one I'm going to add here is side, side angle. So you get two sides and an angle that's not included between those two. That doesn't prove that they're congruent either. Okay, and that pretty much brings to a close 4.3. So go ahead and grab your workbook and do the worksheet on page number, looks like page number 99.